So next is D'Alembert solution of wave equation. So we know that the wave equation is dou square u by dou x square is equal to 1 by c square dou square u by dou t square, or dou square u by dou t square is equal to c square dou square u by dou x square. So by D'Alembert solution, consider u as a function of two new variables v and w, where v is x plus ct and w is x minus ct. So now u will be a function of v and w. Okay. So by chain rule, what is dou u by dou x? U is related to v and w, where v and w are functions of x and t. So dou u by dou x is dou u by dou v into dou v by dou x plus dou u by dou w into dou w by dou x. And dou v by dou x is 1. Dou w by dou x is 1. So it is dou u by dou v plus dou u by dou w. Let it be equation number 2. Then again dou square u by dou x square is dou by dou x of dou u by dou x. That is this one. Expanding, we get dou by dou x of dou u by dou v is dou by dou v of dou u by dou v into dou v by dou x plus dou by dou w of dou u by dou v into dou w by dou x. Because dou u by dou v will be a function of dou u by dou v will be a function of v and w. So we have to differentiate with respect to v into dou v by dou x. Similarly with respect to w, dou by dou w of this one into dou w by dou x. Plus second part, dou by dou x of dou u by dou w also dou by dou v of dou u by dou w into dou v by dou x plus dou by w of dou u by dou w into dou w by dou x. The values are given. So it is dou square u by dou v square plus dou square u by dou v dou w plus dou square u by dou v dou w plus dou square u by dou w square. That is dou square u by dou v square plus 2 dou square u by dou v dou w plus dou square u by dou w square. Similarly, we have to get dou square u by dou t square. It is with respect to t in the differentiate table. Here derivative of v with respect to t is c. Here it is minus c. So here it will be c square into dou square u by dou v square minus 2 dou square u by dou v dou w, because minus 2 വരുന്നത് ഈ പാർട്ട്, that is ഈ പാർട്ട്. അപ്പോൾ ഈ പാർട്ട് ആകുമ്പോൾ dou w by dou x ഉണ്ടാവും, അത് മൈനസ് സി ആയിരിക്കും, ഇവിടെ മൈനസ് സി വരും, അപ്പോൾ നമുക്ക് മൈനസ് 2 വരുന്നത്. ഓക്കെ. So substituting in the given equation, we will be getting minus 2 dou square u by dou v dou w minus 2 dou square u by dou v dou w is 0, or dou square u by dou v dou w is 0. And integrating with respect to w, it will be the integral of dou square u by dou v dou w is equal to integral of 0 dw. That is dou u by dou v is equal to function of v, because integral of 0 is a constant, so it's constant function of v. Again integrating with respect to v, you will be getting u function of integral of f of v dv plus function of w, that is phi of v plus g of w. So u will be phi of x plus v is x plus ct, w is x minus ct. So this one is psi. We can write the g as psi of x minus ct. So phi and psi, which is the general solution of the wave equation using this method, D'Alembert's method. Okay. Next, initial conditions. We set the initial conditions as dou u by dou t at x0 is 0. That is initial velocity is 0 and initial displacement is u of x0 f of x. So that these are the if these are the two initial conditions, then we can differentiate this one with respect to t. So dou u by dou t is phi dash into c minus c into psi dash, and it is given that u of x0 is f of x, and dou u by dou t at x0 is 0. So dou u by dou t is phi dash is equal to psi dash എന്ന് കിട്ടും. ഇനി ഇത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ u of x0 is f of x, that is f of x is phi of x plus psi of x. Again integrating this one, phi dash of x is equal to psi dash of phi of x integral of psi dash, that is psi plus constant. So phi in the place of psi dash plus k കൊടുത്താൽ f of x is 2 psi of x plus k, or psi of x is f of x minus k by 2. Phi of x of f of x plus k by 2 കിട്ടും. Substituting in the u of xt is half of f of x plus ct plus k plus half of f of x minus ct minus k. It is minus k. Okay. Psi of x is f of x minus k. So it will be u of xt will be half of f of x plus ct plus k by 2. Here it is minus k by 2. So f of x minus ct. So u is half of f of x plus ct plus f of x minus ct. So this is the D'Alembert solution. Okay. So for this problem, find the deflection of vibrating ring of unit length having fixed ends with initial velocity 0. So we can apply the D'Alembert's method. Initial deflection is given by k into sin x minus sin 2x. So D'Alembert solution is half of f of x plus ct plus f of x minus ct. So here f of x is k into sin x minus sin 2x. So it will be half of that is k by 2 of sin of x plus ct plus sin of x minus ct minus of sin of 2x plus 2ct plus sin of 2x minus 2ct, that is k by 2. Then arrange ചെയ്താൽ sin c minus sin c plus sin d 2 sin a sin c plus sin d 2 sin c plus d by 2 cos c minus d by 2. ഇതിങ്ങനെ കിട്ടും. Here also sin c plus d by 2 cos c minus d by 2. So it will be the answer. Okay, you can verify whether u of x0 is f of x and dou by dou t at x0 is 0. So this is the solution.